All right, so now we're going to talk about the types of OSPF packets that can be sent out, and we will start talking about the algorithm that implements the operation of OSPF. So as I mentioned in the last video, OSPF sends out what are called link state packets. There's actually several different categories of link state packets that can be sent out. The first one is just a hello packet. This is kind of like the super friendly neighbor that moves into your neighborhood and goes around and greets everybody. So this is just basically an announcement of your existence to neighbors. The second packet type is a database description. This is the link state summary that the sending node currently has. A node can send out a link state request. This would be when a node is either trying to discover a portion of its link state that it is missing, or when it is trying to update information. So we could be requesting missing information, or asking for an update on a link. There is an LS update. This is either a response to an LSR, which is the one that we just talked about, or this is basically an announcement of a change. And then the last one is our LS ACK, which is what we talked about at the end of reliable flooding in the previous video, where this is how we can verify did who we're sending the packets to actually get them. And so what you'll generally see is that hello packets will be sent out at the beginning of the network initialization as all of the routers begin to discover who is adjacent to them. And then with that information, they will start sending out database descriptions. And during normal operation, these will typically be the most common packets where you're seeing requests and updates unless a new router joins the network or a router leaves the network. But during normal operation, the request, update, and ACK are the most common packets. And so just like with RIP, we can either have triggered packets, which think of this as a change in the network, or we can have periodic. packets, which is just kind of, again, that, hey, I'm alive type thing. So let's move on to the algorithm for OSPF. OSPF uses what we call, or what a lot of us might know of as Dijkstra's. This is a shortest path algorithm. So the goal of it is to find us a shortest path, and OSPF basically is saying that I'm going to find the first open shortest path and use that as my route to send packets. Unlike RIP, there is actually an order to how Dijkstra's initiates. Or I should say more like unlike distance vector, Dijkstra's follows an order. So in distance vector, it was kind of whoever got there first. Kind of got to be the best path, because we could end up with equal distance paths to a destination. For example, if we had a network that looked like this, there's two potential routes for A to get to E that are of the same cost. If A went to C, to D, and then to E, that's the same cost as if A was to go to B, to D, to E. And so with Dijkstra's is that Dijkstra's has tie-breaking protocols in it, or a tie-breaking design in it, that would ultimately say there's, for instance, a node value that gives us priority. B is a lower value on the alphanumeric scale than C is, and so the chosen path for A would be to go through B. And so that is something we did not have in RIP, but we now have it in Dijkstra's.